These are our vacuum tables that we have developed especially for machines with manual clamping systems. The tables are intended as an alternative that can be mounted on an existing table when vacuum fastening of smaller parts is needed. The tables can be attached with clamps or via the holes that are prepared on the vacuum table. It is possible to connect several tables in parallel so that you cover the entire table surface if you wish. It is only the pump that sets a limit on how many tables you can have. We have 3 different pumps that we sell, and each pump is adapted to the work to be done. This pump is available in 2 variants, and with a flow of 8.5 cubic meters per hour or 15 cubic meters per hour. RawVac 8.5 is perfect for a vacuum table where the piece is to be attached directly to the table and with a full coverage sacrificial plate. RawVac 15 is a little stronger and can handle 2 or more tables depending on how they are to be used. The strongest pump we have right now is the RawVac 29, which can handle multiple tables at the same time and can easily suck through sacrificial plates and hold small parts in place even during fast cuts. These are oil-free industrial pumps and made for continuous operation. There are those who run vacuum tables with traditional vacuum pumps like this. It works, but they tend to be weaker and require constant oil refilling. They also work in a different way where the vacuum pulses while industrial pumps have a more constant suction. I will connect our strongest pump, RawVac 29, and show you how a vacuum table works. Watch the gauge when I place this acrylic sheet on top. Because it's airtight, the pump can pull the table close to its maximum vacuum. And just to be clear, you can't get more than about 1 bar of vacuum in the real world. That's the limit set by atmospheric pressure. So when it's reading almost max like this, it tells you the system is doing what it should. Good gasket contact, tight surface, minimal leaks. When I turn off the pump, it takes quite a long time before the vacuum releases, which indicates a tight setup. Now let's do something more realistic. This is a 12mm MDF sheet, and MDF is porous, so it constantly bleeds air. That's why the gauge won't hit the same near 1 bar level as with an airtight sheet. The pump is working against continuous airflow, but the important thing is the sheet is still held down hard. And if I add this acrylic panel on top, the vacuum actually travels through the MDF, so it clamps the acrylic too. So I can machine right through the acrylic and into the spoilboard, and the vacuum table stays protected. Now I'll remove the acrylic and switch to MDF again, but this time I'm using a smaller piece. Even though it's sitting on top of another MDF sheet, it still holds really well. But when I go even smaller, you'll notice the difference. It doesn't lock in the same way, and that's totally expected. With small parts, you simply don't have enough sealed surface area, and you're spreading the vacuum over a much larger area than you need. So the fix is simple. Create a smaller vacuum zone. By closing off the rest of the table and only pulling vacuum under this piece, you concentrate the suction where it matters. And now it grabs hard, even on porous MDF. This is the better way to get really strong hold down, even on small parts and without having to mess with zones. Let me introduce you to RawVac Gasket. It's a self-adhesive gasket in a high friction material, and the idea is simple. You stick it onto a sacrificial board. Something like 12mm MDF works great. And that becomes your dedicated vacuum spoilboard. And here's a tip for even better performance. MDF often has a harder, denser surface layer. If you lightly machine that surface off, ideally on both sides, the board breathes easier. That means faster pull down, more consistent vacuum under the part, and better grip overall. We also recommend that you seal the edges with, for example, silicone. The edges let a lot of air through and should be sealed. Alright, now the gasket is on, the pump is running, and this is where it really shines. I'm placing a small piece right here on the gasket, and you can feel it lock in immediately. This is the big advantage of the gasket setup. Even small parts get a strong, concentrated hold down without setting up zones. And at this point, I can machine this piece directly, even do through cuts, and it won't shift or move on me. You can also make the suction stronger by placing dense discs around it, which will further concentrate the suction. Next, I'll add the RawVac gasket, and this is where the workflow gets really fast. I'm only covering about half the table with this MDF sheet, but because it's sitting on the gasket, it seals properly and you still get plenty of suction right where you need it. So there's no waiting around for vacuum to build, and no fiddling with zones. You can basically start cutting immediately. And now I'll run a cut at a pretty good feed rate, just to show that the parts stay locked down and stable even at higher speeds. The parts I just cut are actually quite small, and that's usually where vacuum hold down struggles. But even here, the vacuum kept everything locked in place, so nothing shifted or lifted during the cut. And now for something people always ask about: what happens if you cut into the gasket? In this run, I actually cut about 0.5 millimeters down into the material, so on paper, that should damage the gasket. You can clearly see the tool marks and it looks like it's ruined, but watch this. After a quick vacuum clean and a wipe with a cloth, the surface fibers rise back up, and the gasket looks basically unused again. So with the right settings, this stuff lasts a surprisingly long time. The gasket I'm showing here has been cut into more than 10 times, and you can barely tell. Next up, I'm adding a second vacuum table, and this is one of the nicest parts of the system. You can parallel connect multiple tables using a simple manifold. So the pump goes into the manifold, and then each table connects to its own outlet. On the manifold, I've got individual shut-off valves, so you can turn tables on and off, or run it like zones depending on what you're doing. And the setup scales really well. You can add as many tables as you want, as long as the pump capacity can keep up with the total airflow and leakage from your material. Now, you don't have to start with a big vacuum pump to use these tables. This is a small oil-driven vacuum pump, the kind typically used for refrigeration work. The one I'm using here is 2.5 CFM, which is roughly 4.25 cubic meters per hour. These pumps aren't really designed for vacuum tables, but they can work. With a few caveats. The vacuum builds slowly, and because the flow is limited, you often need to press the material down by hand at first, so it seals, and the pump can start pulling properly. For jobs where you're not doing aggressive through cuts, for example sign making, engraving, light milling, this can be totally fine as a starter setup. But if you want it to feel proper and pull down fast and hold reliably, we recommend at least double the capacity compared to this. Just to wrap this up, if you want a setup that still stays compact but feels much more vacuum table friendly, our RawVac 8.5 pump is basically the next step up, with roughly double the capacity compared to this small unit. For a single table, that's often plenty for a lot of workflows, and with the extra flow, you can run a spoilboard as well. Now I'm adding another table next to it, and once you start running multiple tables, I do recommend stepping up the pump a bit. Our RawVac 15 is an easy match for 2 tables, and in many setups it can handle up to 4, depending on your material and how much open area you're pulling through. If you want to cover larger surfaces more consistently, or run more tables at once, that's when you move up to something like the RawVac 29. And in some cases, especially with very porous spoilboards or big open areas, You might even run multiple pumps to supply enough airflow across the whole system. But the best approach is simple. Start with one pump, test it with your real materials and workflows, and then scale up if you need more capacity. Next, I'm putting a single MDF sheet across both tables. This board is completely unmachined and leaks air, but it's good enough to demonstrate something important. Even though the sheet covers both tables, I'm only placing a workpiece on one side. The other table is basically open, and you can still see it pulling through the MDF and holding the piece down. So even without splitting zones or shutting anything off, there's still enough capacity to get real holding force through the spoilboard. That said, you'll always get better results if you close the unused table or shut off that zone, because then you concentrate the vacuum where you're actually machining, and the hold down gets noticeably stronger and more consistent. Last thing I want to show is what happens with materials that aren't flat or smooth. OSB is a perfect example. First, I'm placing an OSB sheet on a regular spoilboard, and you can see the problem right away. It doesn't seal. It just slides around because the vacuum can't really grab it. Now I'll do the exact same thing on a RawVac gasket, and instantly it locks in hard. No sliding, no guessing. And that's really the takeaway. When the material surface is uneven, rough, or leaky, a gasket makes the difference between it kind of works and it's properly held down. That's it for this guide. Thanks for watching. I hope this answered most of the common questions about vacuum tables, pump sizing, and why gaskets make such a big difference. If you want more details, specs, and setup options, visit our websites and you'll find everything there. And of course, feel free to reach out if you want help choosing the right setup for your workflow.